Well, so we're here for an information session regarding a new degree that we have here in the Department of Chemical Engineering and Material Science, the Masters of Science in Data Science for Chemical Engineering and Material Science. My name is Prodromos Daoutidis, and I'm the founding director of this master's program. I'm excited about it, and I'm happy to tell you a little bit about it. So this is a unique program. Our goal, I'm sorry, I think I skipped a few slides. The motivation for this program starts from the fact that digital technology and automation are very quickly becoming key drivers of efficiency and innovation in the chemical, biotechnology, and materials industry. There is a rapid adoption of artificial intelligence and machine learning in a variety of tasks, from product discovery and design to process optimization and smart manufacturing practices, to automation, to how different companies handle their logistics and their different operations. And there is also a clear realization that industry is best served by a workforce that combines data science expertise with domain expertise. In other words, it is this integration of data science with domain expertise that seems to be an element that is very desirable from our different industrial partners. And the solution of hiring a computer scientist, for example, or a statistician, it may happen to a certain extent, but it is not envisioned as being the solution to the problem of staffing the various positions that are related to digital technology. So there is an industrial need, and this is something that was very clearly conveyed to us in the different meetings that we had with our industrial colleagues. There is a clear industrial need for for students that have a data science expertise integrated with domain expertise, specifically around the materials and chemicals companies. And at the same time, it's an educational opportunity. As a department, we do not have currently a standalone master's program. There's very few master students that, for example, come in as PhD students, don't pass their prelim exams and get a master's degree. Or there may be PhD students that get a master's degree in chemical engineering on their way to the PhD almost automatically based on the courses that they've taken. But we never really had a standalone master's program. We thought a lot and hard about whether to have one. We wanted to find the right educational opportunity and also have one that will meet a clear industrial need. And this program that we just created now, I think it serves both of these criteria. So it is a unique program. To the best of our knowledge, it is unique in the US and perhaps internationally. There are smaller programs, for example, certificate programs that involve taking 2 courses in computer science and 2 courses in chemical engineering, but they don't have the breadth and depth that we envisioned for this particular program. So our goal is to provide a platform that will educate the next generation of engineers and scientists that will be disciplinary experts and work seamlessly with digital technologies. So this program was developed and offered in coordination with computer science and statistics. I like to describe it as a bridge from our department, from chemical engineering and material science to computer science and statistics. It has been embraced enthusiastically by all of our industrial advisors. Our external advisory board, which comprises industrial members for the most part, has been very vocal in supporting this from its inception and even before that, and has very enthusiastically embraced the program once it has been created. And it's clear based on what I have said so far that it basically creates a new market We build it and we hope that this will be a successful program, and indeed it will be received well from industry, and all indications that we have currently is that this will be the case. So what are the main elements of this program? It comprises 30 credits. It can be taken as a Plan C, which is a coursework only program, or as a Plan B if you decide to do a project that could be worth 1 or 2 of these courses, so 3 to 6 credits. It involves a combination of foundational courses in AI, machine learning, computational science, with domain-specific courses. We have structured it in a way that it is possible to complete it in a year, 2 semesters and a summer. You don't have to complete it in a year, but it is possible to do it. And our target audience for the moment is undergraduates in chemical engineering and material science, and also in other related disciplines, such as chemistry, physics, biomedical engineering, mechanical engineering. We have been also discussing and developing an executive version of this program that will be more directly addressed to colleagues from industry, but this is not ready yet for deployment. We hope to be able to have it in place sometime in the next year or 2. So a deeper look on the coursework that is involved in the program. The core curriculum comprises of 3 courses that are foundational and 3 courses that are more application-oriented. So there is a list of some of these courses here. As sample courses, for example, for the foundational courses include applied regression analysis, machine learning fundamentals, and introduction to data mining. This is just a sample. One could substitute 1 or more of these with other courses from the Tier 1 algorithmics track of MS in data science curriculum. This is the program offered by computer science and statistics. And they have different tracks. If you go and check, you will find options that you have which you can take instead of these courses. Although, in my opinion, these 3 courses represent a very good foundation upon which to build an expertise in machine learning and AI. In addition to this, you need to take 3 courses from the chemical engineering and material science computational graduate curriculum. These courses are currently an applied mathematics course, a course on optimization, and a course on machine learning with a more applied character for chemical sciences and engineering in general. So this will give you at least 18 credits, depending on the courses that you have, and that will leave almost 4 courses to complete the degree. These will be electives. These electives could be from the list of chemical engineering and material science graduate courses. And we have a requirement here that if you are a non-chemie MANSci major, you need to take at least 2 of these courses. These are courses on thermodynamics, on transport phenomena, on fluid mechanics, on other more specialized topics in chemical engineering and material science, on structure and symmetry, for example, in materials, and so on and so forth. And the rationale here is that if you're going to get a degree that has a chemical engineering and material science association, it is important that you take at least 2 of these graduate courses that we offer in the department. Also, you need to have at least 1 course from a very broad selection of courses in the statistics, algorithmics, and infrastructure and large-scale computing tracks of the MS in data science curriculum. Again, this is the curriculum as part of the computer science MS in data science program. And here I'm listing another sample of such courses. Here we want you to pretty much have a very broad selection to choose from based on your particular interest. You may be more interested in statistics. You may be more interested in AI. You may be more interested in advanced computing or in robotics or in vision, image processing, or even a course in business analytics. Whatever your interests are, you can choose a course that will be an elective. So here is a sample schedule. Again, this is structured in a way that will satisfy all your requirements within a year. So you can start by taking the foundational courses, a couple of them, and then a couple of the chemical engineering and material science courses. And you can continue like that with the possibility of starting a project sometime in the spring semester. If you are a non-Chemie Mat Sci and you have to take 2 additional courses from Chemie Mat Sci and just 1 more elective course from a more computer science curriculum, then that leaves you just 1 course that you can substitute for a project. And you can choose to do it in the summer, for example. Here are some eligibility requirements. We ask for a GPA of 3.5 or more at the time of application. This is not a strict requirement. We take into account your entire records and your entire academic background when we evaluate applications. We need you to have 2 semesters of calculus, multivariable calculus, linear algebra, and differential equations, and some exposure to undergraduate courses in statistics, advanced programming, and algorithms and data structures. Again, these are requirements, but they can be reevaluated, reassessed, depending on your particular background. For example, if you had some experience in industry or in one of these areas, in statistics or in programming, that can be documented, but you did not have a formal course, we may consider your application and your admission to the program, taking into account all the criteria. We have a deadline of April 15 for the fall admission, and if you decide to apply, you should include your CV, a statement of purpose, and diversity statement, transcripts, 3 letters of recommendation, and also TOEFL for international students, and we will reach our decisions by April 30. So these are the slides that I wanted to share with you, and I wanted to make sure that we have plenty of time for questions. And I guess we can stop the recording and open the floor to questions.